All right, so this is part 2 of today's lesson, or this week's lesson, and this would be notes number 41, I believe, and I'm calling it Transformations of Trig Graphs. And here's the big idea that you need to know for this lesson. We have studied transformations a lot. Transformations are where you shift a graph up or down, left or right, stretch it or shrink it vertically or horizontally, and potentially also reflect it over an axis. Every single transformation works the exact same way no matter what kind of function you have. So if you're looking at transformations of trig functions, they work exactly the same way as they worked with exponential functions, polynomial functions, quadratic functions, linear functions, absolute value functions, and on and on and on. So that means that you already have the knowledge you need to be able to do transformations of trig graphs. I have to keep it really, really brief this year and only go over this topic a little bit because obviously we hardly have any time together. So I want you to know that what I'm going over with you here today is just not really enough, but it's all we can do. And we're not going to be able to do the application problems this year that we normally would. So sorry to those of you who are looking forward to story problems on this, but we just have to cut some things. So that's one of the things that's being cut down quite a bit. Okay, here we go. I have 8 problems for us to work through. And we're going to start with number 1, graph y equals sine of x over the interval from negative 2 pi to 2 pi, state the period and amplitude. This should look familiar if you just did the first part to the first video because we practiced all of these. So draw your axes, label your x-axis with negative 2 pi and 2 pi, label your y-axis with 1 and negative 1, make 4 sections in your region between 0 and 2 pi, and 4 sections in your region between 0 and negative 2 pi. I'm trying to get this to look better. Okay, that's a little bit better. All right, now remember the sine graph goes through 0, 0. So we start in the middle and we go middle, top, middle, bottom, middle. There's one sine curve. Same thing on the other side, bottom, middle, top, middle. There's another. Okay, the period is the width of one cycle. The period is 2 pi. The amplitude is the distance from the middle to the top. The amplitude is 1. Now, what we're going to do for problem number 2 is graph y equals 2 times the sine of x. So I want you to stop and think about what does it do to a function if you multiply it by 2. No matter what kind of function it is, if you multiply it by 2, you're going to stretch it vertically twice as tall. So we have a vertical stretch times 2. Okay, so we're graphing that. Well, I didn't give myself a whole lot of room to make this look taller than my other one, but what I can do is just change my scale. So I'm going to go up to 2 and down to negative 2 on my y-axis. If you want, you can make your graph look taller by making your 2 and your negative 2 farther from your origin compared to how I'm doing mine. Okay, from here, same thing we did before. Start at the middle, 0, 0. Go up to 2, down to 0, down to negative 2, back up to 0. And then other side as well. Middle, bottom is negative 2, middle, top is 2, and middle. Okay. What's the period? What's the width of one cycle? Did changing the height change the width? It did not. So the period did not change. It's still 2 pi. What's the amplitude? The distance from the middle to the top. Did changing the height change the amplitude? Absolutely. Now the distance from the middle to the top is 2 instead of 1. Okay, problem number 3. Graph the opposite of 1/2 of sine of x over the interval from negative 2 pi to 2 pi. Notice there are 2 transformations there. One transformation is because of the negative sign, and the other transformation is because of the 1/2. Label your axes. Divide into 4 equal chunks. Okay, what's the negative going to do? The negative is going to cause the graph to reflect across the x-axis. That's what always happens no matter what kind of function we have. When we multiply it by a negative, all the positive y values go negative, all the negative y values go positive. It reflects across the x-axis. And what's the 1/2 going to do? That's going to be a vertical shrink. Half as tall. Okay. So it's still going to go through 0, 0. Now we're going to go up to a height of 1/2 and down to a height of negative 1/2, not up to a height of 1 and down to a height of negative 1. However, remember we have to flip this thing upside down. So we're not going middle top, we're going middle bottom, middle top, middle. There is a reflected sine graph, half as tall. And then we can do the same thing on the other side. Okay? What's the period? Did reflecting it change the width? It did not. Did vertically shrinking it change the width? It did not. So the period is still 2 pi. What's the amplitude? Okay, amplitude is always positive. It doesn't matter if you multiplied by a negative and you had a reflection. Amplitude is just the distance from the middle to the top, always positive. So the amplitude is positive 1/2. That's the distance now from the middle to the top. Okay. Now, let's do a couple more transformations, and I'm going to use cosine instead of sine. These transformations work on every trig function. I'm just trying to keep it easy for us, and I think doing it with sine and cosine is going to be easier than trying to do it with tangent or any of the others. All right, so the regular cosine graph, label your axes. And then remember cosine goes through the point 0, 1, so we're at the top, middle, bottom, middle, top. There's one cosine curve. And then same thing on the other side, middle, bottom, middle, top. There's another cosine curve. What's the period? The width of one cycle is 2 pi. What's the amplitude? Distance from the center to the top is 1. Okay, now we're going to graph y equals cosine of 2x. Notice the 2 is inside the function, not outside the function. And remember from our study of transformations, if you multiply by a number on the inside, it's not a vertical change, it's a horizontal change. So this is going to be a horizontal, either stretch or shrink. We have to figure out what. And this is the one that's not what we expect. We would expect multiplying by 2 to make it bigger. Actually, when it's on the inside, multiplying by 2 makes it smaller. In other words, it's going to shrink it. Horizontal shrink. You can go back to your notes on transformations and you can see that that's what happened with all the other graphs we've transformed. So it's going to be narrower. Okay? So how do we graph that? We're still going from negative 2 pi to 2 pi. We can still put a 1 and a negative 1. Break it down. However, now it's going to complete one full cycle in half the width. So it's going to complete one full cycle by the time it gets to pi, rather than by the time it gets to 2 pi. So maybe I should make more marks then. Divide those halves in half, divide those halves in half, divide all of those halves in half. Okay, so cosine starts at the top, middle, bottom, middle, top. There's one complete cycle. We're going to do it again. Top, middle, bottom, middle, top. There's another one. We're going to do it again. Top, middle, bottom, middle, top, middle, bottom, middle, top. We go until we reach the endpoints of our interval. Okay. Do you see how that looks 2 times narrower? Because of the 2. Notice that we have 4 full cycles in there. 1, 2, 3, 4. What's the period? The width of one cycle. We have twice as many now. It's no longer 2 pi. Now it's just 1 pi. The period is 1 pi. What's the amplitude? Did the horizontal shrink affect the height at all? It did not. So the amplitude is still 1. Okay, here's how I would like to remember what's going on here. I like to think of the cosine graph as a roller coaster. And whereas the original roller coaster looks like fun, this new roller coaster looks like 2 times the fun. Get it? 2 times the fun because of the 2x in there. So if you see cosine 2x, think to yourself, 2 times the fun, twice as many curves. Same thing for sine. If you see sine of 2x, 2 times the fun. If you see cosine 3x, 3 times the fun, 3 times as many curves. Okay, let's do number 6. This is cosine of 0.5x, or 1/2 x. Guess how much fun it is? Half the fun. What does it mean to be half the fun? You're not going to get to go up and down as many times, so it's going to be wider. So this will be a horizontal stretch. It's going to look wider, 2 times as wide. So let's go ahead and see what that's going to look like. We're still graphing from negative 2 pi to 2 pi. But here's the thing. You're not going to make it through a full cycle in a width of 2 pi. You're only going to make it through half a cycle. So you're going to go top, middle, bottom. That's all you get because it got wider. Then on the other side, same thing, top, middle, bottom. Notice that is one full cycle, and what's the width of that full cycle? That width is 4 pi. So the period of this one is 4 pi. And what's the amplitude? Did widening it change the height at all? It did not. So the amplitude is still 1. Okay, let's keep going. We have 2 more to do. And number 7 involves a vertical shift. And then number 8 is going to combine a vertical shift with a stretch. So we're graphing y equals the sine of x plus 1. What does it do to every graph you've ever transformed if you add 1 to it? You add 1 to the outside, it moves the whole graph. How? I want to hear you say it. Or show me with your hands what's happening. I'm watching you. Good. It moves the whole graph up 1. So this is a vertical shift up 1 unit. Okay. So we're going to graph this. You know what? Now, instead of our graph going up to a height of 1, our graph's going to go up to a height of 2. So here's how I like to take care of a vertical shift. Let's look back at our original sine graph. Okay. I like to say that we have a midline, the line that cuts through the middle horizontally. I like to call that the midline. Normally, the midline of a sine or a cosine graph, or any of the trig graphs, is at a height of 0. But if you shift it up or down, the midline is going to shift. So in this case, shift the midline up 1. Okay? You can even draw that in place. That's the midline. So remember that normally sine starts at the middle. I'm going to break my intervals into 4 equal chunks. Start at the middle, but now the middle is not at 0. Now the middle is at 1. Middle, top, middle, bottom, middle. There's your sine graph shifted up 1. You can do that on the other side as well. Okay? What's the period? Did shifting it up change the width at all? No, it did not. So the period is still 2 pi. What's the amplitude? Did shifting it up change the difference between the middle height and the top height? No, that is still 1 unit. So the amplitude is still 1. And then number 8, we're combining a couple of transformations. We have what kind of vertical change? Can you tell from the -1? That would be shift how, I'm listening, shift down 1. So we're going to draw that midline, we're going to draw it in lower. And then what does this 3 do? Remember that from earlier in the lesson? That's going to be a vertical what? A vertical stretch. 3 times as tall. So let's plan this then. We have to shift the whole thing down 1, and we have to go 3 times further. So we're going to need more room on our y-axis. I'm going to go up to 2 and down to -4. Put the 2 pi in there, put the -2 pi in there, break those into 4 equal chunks. Notice that I did not change anything horizontally. I just have the vertical shift down 1 and the vertical stretch 3 times as tall. So let's put that midline in place at a height of -1. And then this is a sine graph, and so we want to start at the middle. And then we're not going up 1 to the top, we're going up 3 to the top, and then back to the middle, and down 3 to the bottom, and then back to the middle. Same thing on the other side. Down to the bottom, back to the middle, up to the top, and back to the middle. Okay. I hope you will ask me questions about that if any of it doesn't make sense. What's the period of this one? Did either of those changes affect the width? They did not, so the period is still 2 pi. What's the amplitude? Did either of those changes affect the distance from the center to the top? Absolutely. The distance from the center to the top is now 3, so the amplitude is 3. Okay, so your assignment is to graph each of these functions over the interval from -2 pi to 2 pi, state the period and the amplitude. I will post a video showing how I do these in case you get stuck and need help. You can always ask me also, but I figure if I send out the video to everybody, it will probably take care of some of the questions. And then I will also just post the PDF of the answers. Thanks, everybody.